Welcome to our lesson on the solar system and the universe. To start off with, I'd like you to answer the do now questions from your prior learning on Newton's laws. Okay, so pause the video, answer the questions. Okay, so to calculate the force required to accelerate a car of mass 1,000 kilograms at a rate of 10 meters per second, we're simply going to use F equals ma. Okay, and we're going to substitute in our mass is 1,000 and our acceleration is 10. So that's going to give us 1,000 times 10, which equals 10,000. Okay, we're not finished there because it's force. We're going to use newtons. Okay, why do falling objects reach terminal velocity? Okay, very simply, the weight balances. Okay, so it's equal and opposite to the air resistance. Okay, so as that falling object gets faster and faster, there is more air resistance. When the force is balanced, there's no longer an acceleration. Okay, so what effect does the resultant force have on an object? Okay, so we're either going to get acceleration, deceleration. Okay, so getting slower, or change direction. Okay, so all of those would be a type of an acceleration, yeah? Get faster, get slower, change direction. Okay. So today we're finding out about the solar system and the universe. You're going to describe the features of the solar system and the universe. You're going to identify features of the solar system and universe, describe the features, and apply learning to produce high-quality responses to our past paper questions. Okay, so first thing I'd like you to do is, on your booklet, you need to write in the order of these from largest to smallest. Okay, so we've got the Sun, the solar system, the Earth, Milky Way, galaxy, Jupiter, the Moon, the universe, and a comet. Okay, so just pause the video, and then you can write those in order in your booklet. Okay, so from largest to smallest, we have the universe, which contains everything. Okay, all energy and all matter is in the universe. Then it's the Milky Way galaxy, which is a collection of stars, many, many stars. The solar system is the next smallest object. Okay. Then we have the Sun, which is our star at the center of our solar system. Then we have a gas giant by the name of Jupiter. Then we have the Earth, which is a terrestrial planet, a rocky planet. Then we have a moon, our moon, which is a natural satellite of the Earth. Okay, and then we have a comet, which is basically a dirty ball of ice that has a very elliptical orbit. It comes very close to the Sun, giving us our tail, which always points away from the Sun, and then it will go very far away from the Sun into deep space before returning years later. Okay. So the scale of the solar system, the Earth is approximately, well, a huge number of kilometers away from the Sun. Okay, it's a ridiculous number to write down. If we were to ask you to do calculations about this, it becomes very difficult straight away, not because the calculations are difficult, but because the numbers are so large. So instead of using such large numbers, we use astronomical units to compare and measure distances within our solar system. Okay, so one astronomical unit is simply the average distance between the Sun and the Earth. Okay, so if we look at our table that's in the bottom right corner there, we can see that the Earth is one astronomical unit away from the Sun on average. Okay, that's the average distance. Okay, and we can easily compare the distances for these other planets from the Sun in comparison. Okay, if we look at these numbers, they're just all huge. Okay, it'd be very easy to lose place value. This makes it much more simple, more straightforward to compare those values. Okay. Similarly, when we look at the scale of the universe, using astronomical units would be ridiculous. Kilometers even more ridiculous because the numbers would be massive. So what we use instead is light years, okay? And 1 light year is simply the distance light can travel in 1 year, okay? We know the speed of light is going to stay the same. We multiply that by the time it takes, and that gives us the distance, okay? Obviously, the time would be a year in seconds, okay? So 1 light year is a huge number of kilometers, okay? Just the distance light can travel in 1 year. Okay, so what I'd like you to do on this page is label the objects in the diagram, okay? If you can label the terrestrial planets and the gas giant planets as well, that'd be fantastic, okay? You should know most of these yourself, and then we're going to go on to the next slide, and we will name them together, okay? So press pause, and then complete your diagram, and then we'll name these together, okay? Okay, so starting off on the left-hand side, obviously we have the sun. Okay, and then we have our terrestrial planets on the left-hand side, closest to the sun. So we've got Mercury, Venus, Earth. So Earth is the one that we're actually living on. Okay, Mars. Okay, the next bit is this dotted line, and that is our asteroid belt. Okay, Jupiter, Saturn, Uranus, and then Neptune. Okay, and this little fella is just over here. Okay, is a comet. We can tell it's a comet because it has its tail pointing away from the sun. Okay. Okay, we used to have an extra planet, which was Pluto, but Pluto is now deemed to be a Plutoid or a planetoid or a dwarf planet, and it's no longer classified as a planet, okay? That's because there were loads and loads of other dwarf planets around about the same size that were discovered after Pluto's discovery. That kind of made it irrelevant. We couldn't have had that many planets in our solar system, so it's been moved down, declassified from a planet to a dwarf planet. Go back and... Yeah, Mars and Jupiter, that is correct. Okay, right, so some review questions. Again, if you just pause the video, you can answer these questions. Okay, so true or false, let's correct the incorrect ones. A light year is the average distance between the Earth and the Sun. That is incorrect, so we could either change that to astronomical unit, is the average distance between the Earth and the Sun, or a light year is the distance travelled by light in 1 year. Okay, terrestrial planets are made from dense gas. That's incorrect. Okay, so we could have gas giants are made from dense gas, and obviously terrestrial planets are the rocky planets. So Mercury, Venus, Earth, and Mars are terrestrial planets. That is true. The asteroid belt is found between Mars and Jupiter. Well, that is true. Okay, comets have circular orbits. That is incorrect. They are elliptical. Okay, so an ellipse is basically a squash circle or an oval. A moon is an artificial satellite that orbits around a star. That is incorrect. It's a natural satellite that orbits around a planet. Okay, right, so some core knowledge questions for you. So there's 9 core knowledge questions. You need to answer these questions, okay? If you're not sure on the answer to any of these after our lesson, go back and watch the video again, or alternatively, you go and look at BBC Bitesize. You need to go to Key Stage 4 in Wales and click on WJC, and then obviously you're studying physics. But you should be able to answer all of these from your learning today. Okay, and then there's some past paper questions. Okay, so these are in your booklet as well, so you just need to answer these questions using information either in the questions or from your learning today. Okay, there's another question, there's information there we need to read through, answer the questions. Again, same sort of thing, we need some ticks or crosses in those boxes. And finally, our solar system consists of the sun along with a variety of different objects and planets. Name these and describe some of their features and their relative positions. Okay, it's worth 6 marks, as you can see here. Okay, all I want from you is a series of bullet points and write down the names of those different bodies. Okay, and then write a little bit about them. Okay, so obviously we've got the sun at the center, which is our star, gives off heat and light. Okay, and you can go from there. Okay, any problems, I'll be able to respond to your questions in the chat function. Good luck with your learning. Make sure you submit at the end of the lesson. Okay, thank you very much. Have a good day.